Good morning, folks. This is Mike coming at you with yet another video on Introduction to Algebra. In the previous video, we talked about some special factoring techniques. In this video, we are going to talk about a new type of equation and how we solve it using a particular property. It's a very basic property, but it's a very important property, especially in this section. So the type of equation we are going to be looking at in this section is what's known as a quadratic equation. So I guess first we should really clarify what the heck do we mean by quadratic. When we talk about a quadratic expression, we're talking about something that looks like this. Some number a times x squared plus some other number b times x plus some other number c. This is referred to as a quadratic expression. Yes, it is a trinomial. We've done a lot of work with trinomials over the last few videos. But really what makes it a quadratic is that the highest power of x is 2. So some number times x squared plus some other number times x plus some other number c. So a quadratic equation, therefore, is an equation that can be written in the form a times x squared plus bx plus c is equal to 0. Taking a quadratic expression such as this and setting it equal to 0. A, b, and c are all real numbers, just like over here. And the big thing is that a cannot be 0. A cannot be 0. B can be 0, and c can be 0, but just a cannot be, because we need an x squared term happening in there. And when we have our equation in this form here, it's referred to as standard form. So these are examples of quadratic equations right here. 5x squared plus 2x equals 1. It's not already given to us in this nice standard form, but I can put it in this standard form. All I have to do is subtract 1 from each side. Similar kind of thing here. X squared equals negative 2x minus 1. Again, it's not given to us in standard form, but we can easily put it in that standard form by moving these two terms over to that left-hand side. And 2x squared is equal to 72. This is also a quadratic equation. Again, clearly it's not in standard form, but I just wanted to clarify that this is a quadratic equation because the number in front of the x squared is not 0. Yes, there's no x term in that is flat out written here, but secretly we have it. I can rewrite this thing as x squared plus 0 times x equals 72. This is the same thing as that, because 0 times anything gives me 0, and if I add 0 onto anything, I just still have that same thing. So this is a quadratic equation. It's just that for our x term, the number in front is 0. This is also an example of a quadratic equation. We have the x squared term, we have the x term, we don't have the constant, but that's okay. It's like our c value here is just 0. So these are all examples of things that are quadratic equations. Now, the big property that we're going to use to solve quadratic equations is the zero product property. And here's what the zero product property says. It says if A and B are real numbers and the product of A and B is equal to 0, then either A equals 0 or B is equal to 0. It's saying that if the product of two things is 0, then at least one of those things has to be 0. The only way that you can multiply things and get 0 is if at least one of those things is 0. And this applies to the product of 3 or more numbers as well. What we're going to see when we solve these problems is that we don't even have to have the products of just numbers. We can have the product of, say, 2 or 3 or more algebraic expressions. So we'll say works for algebraic expressions 2. And this is what we're going to focus on in this video and in this section. So here's what we're going to do. Here's how we're going to solve quadratic equations. First thing you're going to do, given your equation, you're going to write it in standard form. Then you're going to factor that thing completely. You could have a binomial, like we saw in either of these two cases here. These are going to be binomial quadratic equations. I realize now that I said at the start of this video, I said that quadratics were trinomials. That's my fault. They're not always trinomials, but for the most part, they will be. So you could have a binomial or a trinomial as a quadratic equation. So you are going to factor your quadratic equation completely. Then you're going to set each factor that has a variable equal to 0. You'll then solve each resulting equation. So you'll have, say, two factors there. You'll set each factor equal to 0, and you'll solve for your variable in each of those cases. And then you will check each solution that you found, and you will write the solution set. So let's kick it off with some sample problems here. X squared plus 5x plus 6 is equal to 0. This is already given to us in our standard form. That's perfect. So I will lower this so we can stick with the process. So I need to factor this thing completely. Well, this is a nice trinomial here. And by nice, we mean the number in front of the x squared is just 1. So I need two factors, two binomials. They each have just x's as the first term. And now I need numbers that multiply to 6, positive 6, and add up to positive 5. Well, if you think of factors of 6, it shouldn't take you too long to find that I need positive 2 and positive 3. Those multiply out to 6 and add up to 5. So this is this thing factored, and that is still equal to 0. Here's where that zero product property is really coming in now. I have this thing times this thing, and the product of these things here is equaling 0. So that tells me that either this is equal to 0 or this is equal to 0. Now, if you've done this before, maybe you've formed your sort of T-chart. If you haven't seen this, it's a very common thing that is done. You sort of separate each of your factors. You give yourself some room underneath. And now, step 3 here, we're setting each factor that has a variable equal to 0. So this has a factor, so that's being set equal to 0. This has a factor, so that is being set equal to 0 as well. And now we just solve for x in each of these cases. And it's straightforward to find that x is equal to -2 there, and x is equal to -3. Now you can check, take each of these numbers, substitute back into the equation as given, and you will find that you come to find that the left and right hand sides are the same. Each of these x values does indeed make that thing equal to 0. So the solution set, you could just put the values inside of set brackets, or if this were being handwritten, I would have no problem with you saying x equals -3, comma, -2. This one here is very similar to this one, so I'm going to let you try that one on your own. Let's go down to 4x squared equals 1. So this is not already given to us in that nice standard form, so we need to put it in that standard form. And for the sake of having the nicest thing to work with possible, I'm going to add a note up here next to the first step here. If you have to move terms, so that the x squared term has a plus sign or a hidden plus sign in front of it. Move terms so that the x squared term is positive. There's no minus sign in front. So when I have to move terms here, there already is a plus 4 here. So let's leave this term as it is. Let's move the 1 over here, and we do that by subtracting 1 from both sides. So I have 4x squared minus 1 is equal to 0. So I have 4x squared minus 1. I need to factor this thing. If we think about our previous video, 5.4, special factoring techniques, I'm taking the difference of two things. Are each of these things perfect squares? Because if they are, then we have a difference of two perfect squares, and we know how to factor this. So the 4x squared, well, 4 is 2 squared, and x squared is obviously x squared. So 4x squared is the quantity 2x squared. And then 1 is obviously 1 squared. So this thing right here, 4x squared minus 1, recalling our formula for the difference of two perfect squares, the first terms are the same, the second terms are the same, and we just change the signs in the middle. So saying 4x squared minus 1 is equal to 0, we factor that 4x squared minus 1, it gives us 2x plus 1 and 2x minus 1. Okay, we factored this thing. Now we take each factor, set it equal to 0, and we solve for x. So we should all be completely comfortable with this by now. It should not take you long to find that x is equal to negative 1/2 in this case, and x is equal to positive 1/2 in this case here. You can check each of these numbers, plug them into the equation as given. You will find that they do each make that equation true. So your solution set, negative 1/2, comma, positive 1/2. Okay, let's try this one here. 5x squared equals 4x plus 1. Once again, we want the x squared term to be positive, so it currently is. Let's move these two terms over onto the other side. So I have 5x squared minus 4x minus 1 equals 0. And now this is not so nice of a trinomial. We need to use our factor by grouping technique from section 5.3. So I need to think of numbers that will add up to the negative 4 and will, add up to the negative 4, and it will multiply to the product of the 5 and the negative 1. And the product of 5 and negative 1 is negative 5. So, thinking of some numbers here, factors of 5, keeping in mind that one number has to be negative and the other has to be positive. It shouldn't take you too long to find that the numbers we need are negative 5 and positive 1. So I'm going to take this middle term, that minus 4x, and I'm going to write it as the sum of negative 5x and 1x. So going down here, I have 5x squared minus 5x plus x minus 1. That's equal to 0. I group my first two terms, and I group my last two terms. The GCF of these two terms is 5x, and when I divide that out, I get x minus 1. And then the GCF of these two terms is 1, and that's times x minus 1. Pull out the common factor of x minus 1. And now we have our product being equal to 0 here. Form your chart. Set each factor equal to 0. And solve for x. Here you find x is equal to 1. Here you find x is equal to negative 1/5. And you can check each of those numbers, and they do indeed work. So your solution set, -1/5, comma 1. And I better be sure that I use the correct bracket there. We'll do one more here. These three, I'll let you try on your own. We'll go to 5z squared minus 10z. Again, get all the terms onto one side. We want the z squared term to be positive, so it currently is. Let's leave it there. I'll subtract the 10z from both sides. Something like this, if you have a z squared and a z term, or an x squared and an x, see if you can pull out the greatest common factor first. So what is the greatest common factor between these two terms? Well, it's 5z. And what do you have left over? You have z minus 2. So seeing an x squared and an x only, that's sort of your visual cue to, okay, probably want to pull out the greatest common factor here. So GCF to factor. Now, this is a factor. That contains a variable. That contains a variable. We have it factored here. Set each factor equal to 0, and you find that z is equal to 0 there, and z is equal to 2 there. So these are the two values, 0 and 2. So guys, that's how we solve quadratic equations using the zero product property. You know, I mean, this is a very common thing that is done. Some of you may have already worked with this, and this may not be completely brand new to all of us. But it is very important to know how to do. If you have any questions or comments, please be sure to reach out to me, guys. Emails, phone calls, voicemails, in-person visits, Blackboard Collaborate sessions, carrier pigeons, whatever. Until the next video, take it easy, guys.